Assalamualaikum warahmatullahi wabarakatuh and very good morning to everybody. Welcome to lecture 5 of ARC5502 Energy and Architecture. In this lecture, we will talk about renewable energy. We will be starting with the overview of renewable energy, the global scenario, and then we will look at into details of the first type of our renewable energy, that is wind energy. Okay, I want you to think about this first slide. It is showing the carbon dioxide intensity per kilowatt hour of various fuel resources. This shows that the intensity of carbon dioxide produced for every usable energy measured in kilowatt hour of various um, fuel sources. You can see that all those listed are mixed of few fossil fuel, mostly fossil fuel, um, that can be found in our energy production system, mostly being used to fire our electricity power plant, but also in other form as well. Okay, first, the one that you should look at is sustainable wood is considered zero carbon dioxide emission per kilowatt hour. Why? Because the woods are the timber or the biomass is planted for energy. So whatever is released was purposely captured when the tree or the plant is planted. So it's a zero um, balance of carbon dioxide emission, provided that the wood or the timber is farmed from sustainable planting or plantations. And then right at the bottom, you see that it's also timber. It has the highest carbon dioxide emission. This is because when you use you burn timber from non-sustainable resources, all the carbon dioxide captured in the uh, in the body of the plant is being released. So it is very important for us to understand the carbon cycle of how carbon dioxide enter into the energy scenario. And then we move on again from natural gas, moving up to LPG. Um, Natural gas has the lowest carbon dioxide emission per kilowatt hour compared to other form of fossil fuel. As you can see here that it moves up. As you move up, you can see that the carbon dioxide emission per kilowatt hour is rising. LPG, refinery gas, gasoline, kerosene, crude oil, diesel, fuel oil, coal, lignite, and peat. So you see that hard coal is somewhere up there, even though in this chart is down there. That means it has high carbon dioxide emission content. But yet, coal is the most the source that being used the most in our global scenario now. Okay, um, why are we talking about renewable energy? Because first we have explored before that energy is in crisis. If we are not careful, the whole global civilization will run out of energy. So we are looking for energy sources that is long lasting. We know that the fossil fuels, gas, petroleum, diesel, coal, all these are coming to an end in decades, not even centuries, if we continue business as usual. So we need to look for alternative. And then there's another criteria. Even though the sources are renewable, but if they cause um, significant damage to the environment, then it cannot be considered as sustainable. Okay, so first criteria, it must be an abundance. That means almost that it seems that it will not finish soon. And secondly, it does not impact the environment. This is why nuclear energy is not considered renewable, even though in effect it will provide almost um, limitless source of energy for global civilization, but the impact it has on the environment render it unsuitable to be considered as renewable energy. Talking about coal, one of the energy source that emits the highest carbon dioxide and cause the most problem, uh, we can see that China is leading everybody in terms of coal power plants under construction in 2018. That means it is looking at expanding to burn more coal than anybody else. As we know that this has something to do with the economic rise of China. When you are expanding economically, that means you are producing more goods. You need a lot of energy to produce those goods. Okay, this is followed by India, Indonesia, Vietnam, Japan, South Korea, Poland, Pakistan, and Philippines. And we can see that none of the developed country, the Europes, the North Americans, are not pursuing coal as um, the energy source for their civilization anymore because of the problems. So again, uh, we revisit the meaning of renewable energy. There is no clear definition, but it is generally agreed that it includes energy derived from natural processes that do not involve the consumption of exhaustible resources such as fossil fuels and uranium. So the criteria, like I said before, it must be long lasting. It will not come to an end. So fossil fuels is coming to an end. In 50 or even 100 years time, we will run out of fossil fuel. So that is something we need to think about. And secondly, it does not impact the environment to the detriment of biosphere. That's why even though uranium or nuclear energy seems to provide limitless amount of energy, it cannot be considered renewable because of the threat to the environment it poses. Okay, so there is the list of renewable or the list of energy that is being used these days. Try to identify which of these are renewable. Okay, fossil fuel, nuclear, wind energy, photovoltaic, tidal wave, ocean, biomass, so on and so forth. So, as we know that using the two criteria above, fossil fuel and nuclear energy are not considered renewable. Or nowadays we talk about clean energy. Wind, photovoltaic, tidal, ocean, and biomass can be considered uh, renewable. Okay, and another one is hydroelectric. It can be considered renewable because the rains provide uh, potential energy to higher level reservoir in the lakes and water reservoir. These provide continuous energy, but then again, you need to think about the environmental impact. Mostly when you have this large hydroelectric power plant, you need to flood a large amount of land to the point that sometimes you have to alter the ecology of the place. Animals, trees, plants, and to some extent, people have to be removed from the area. And this pose the question whether hydroelectric energy can be considered renewable or not. Okay, biomass, like I said, for example, the timber fuel that we talked about just now, if it is sustainably planted, then it is considered renewable. It produces carbon dioxide to the environment, but the carbon dioxide was captured by the tree or the wood itself before it was being burned. So it almost like contributes no carbon dioxide to the environment because it just maintained what was already there. Okay, even in renewable energy, you can classify them into two type of use: direct use and indirect use. Direct use means that you can use the energy as it is. For example, you use when we were in primary school, we used lenses, magnifying glasses to burn stuff, to burn papers, so on and so forth. We use the energy directly. The heat is being used as heat to burn things and to create heat energy source. Geothermal heat pumps, where we extract heat from deep underground, from the from the earth core, where it is very hot, and we use this heat directly to heat building in cold climates. Okay. Windmills, the traditional windmills in Holland, where you see a lot of these, the kinetic energy of the turning blades being used to power the machine or the contraption that grind grains to produce flour. So this kinetic energy is being used directly. There is no conversion. Examples of indirect use are wind turbine, wind generator, where the kinetic energy of the wind turns the blade, and the turning of the blade rotates the dynamo or the electric motor inside the wind turbine to produce electricity. Okay. So it's from kinetic to electrical energy. Same as photovoltaic cells, we use the energy and the ray of the sun and we turn it into electricity. So it's not direct use. Okay. And fuels from biomass can be direct if you just, for example, you burn a piece of timber to get heat and light from it. That is direct use. But if you use the biomass to produce other fuel, for example, ethanol, then it is called indirect use. So these are the two ways of using renewable energy. So the advantages of renewable energy, as you know, that there should be no greenhouse gas emissions. It should be widespread and abundance. It will provide energy for us for a long time. And most of these are powered by the sun. If you think about it, wind energy is actually energy from the sun. When the sun hits the surface of the earth unevenly, you create high and low pressure, and particle of air move from high pressure to low pressure and create wind. So it comes from the sun. Same as biomass. Trees collect all this carbon dioxide and lock it inside its body as a potential chemical energy. But to do that, they use photosynthesis. And what is photosynthesis? The use of solar energy to turn carbon dioxide in the air and water to produce carbohydrates, to produce cellulose. And these are chemical energy. So it's again from the sun. Except geothermal. Geothermal energy from lava, from the core of the earth. These are gravitational energy. It causes heat from the compaction of masses, pressure of masses over the core of the earth, and this produces heat. So these are renewable energy, not from the sun. And also, if you have, we talk about fusion and fission energy, the chemical explosion or inside the sun itself. These are renewable energy in the sense that there is a lot of it, and it seems to be limitless, even though theoretically it will finish maybe in a million years or so, but it provides a lot of energy. Okay. So the global trend, people are realizing that we need to use to source our energy source from renewable resources. So the trend is rising. You can see that in 2012, the world relied on 13% of its total primary energy supply from renewable sources. And in 2013, it rose to 22% of global electricity generation. Okay, and there's a report by International Energy Agency saying that in 2015 that the share should be reached at least 26% in 2020. So that's a good sign. As such, we architects must be aware of this shift, and where we can specify the use of renewable energy in our buildings. So this is what it looks like and up to 2019. Okay, you can see that most of the energy we use are from biomass, coal, oil, gas. These are all um, apa ni, the last three, coal, oil, and gas, are fossil fuel, which means that we should avoid using that. Yet you can see from the chart that we are using most of our, we are sourcing most of our energy from these sources. And you look at the renewable parts only on the top bits, the modern biofuels, other renewables, solar, wind, hydropower. So not still not significant compared to the way we use other forms of energy. I want you to look at these slides because I think this is interesting to think about. Okay, this is data that I get from International Energy Outlook 2020. It was published by this organization looking at the trend of energy use in the world. Okay, using the scenario in 2019 as a reference case, they do a projection in the future that in 30 years time, that is in 2050, the world will consume energy 50% more than we consume today. Okay, so this is quite high if you understand the development of the progress of exponential growth. This is quite worrying. 50% in 30 years, that means 60%. In 60 years, we will need double the energy we are using now. Now, looking at the second data, it says that 3% of global GDP growth per year. That means by 2050, the growth would have been 150%. Um, if you combine these two data, and you remember the concept of energy intensity, that is the GDP per the energy use per GDP growth. That means good, we are doing good. We produce more economic growth with less energy. It seems that the economy is rising, is expanding by 150% in 30 years, yet our energy consumption only expanded by 50%. Because like we explored before, that this means that energy efficiency is rising. People are being careful about how efficient their machines, their buildings, their factories are using energy. This is something good. But looking at the third information there, that is 0.7% of global population growth per year. That means by 2050, the global population had grown by 21%. And this begs question, why we consuming more energy when the growth of population, the number of people in the world is rising only by 21%. Yet the energy we use expanded by 50%. That means it means that in 30 years time, a person would have consumed twice as much energy as we would have consumed now. So this begs a question, what are we doing now that in the future every human will need twice as much energy? We have not grown taller, we have not grown any extra limb. We are still the same biological species, but yet our energy consumption doubles in 30 years. So this is something for us to think about as architects. Um, we can try to strive that our buildings are more energy efficient. Our cities, our transportation systems use more energy efficient engines, so on and so forth. But yet, our overall consumption or our overall need of energy doubles. So I think this shows that there need to be a change in the paradigm of how a human function in the world. Why do we need more stuff? Why do we need to travel more? why we need to consume more as time goes by. So I think this is a very important question for us to reflect. This is an interesting projection, but looking at our the world electricity. Okay, now we look at the carbon intensity of electricity generation. The main form of energy we use in buildings, we use electricity. Um, so you can see that CO2 in terms of carbon dioxide emission, the fossil fuel is the main culprit. Natural gas, oil, and coal right at the end there. It surpasses most of the other form of energy. Hydro has the least CO2 generation, but I don't know whether this is true if you consider that some of the hydroelectric power plant, they flooded a huge tract of forest um, that it threatens wildlife, so on and so forth. Of course, when they flooded this forest, all the CO2 are trapped inside the body of the rotting plants, so on and so forth. So there's no really carbon emission, but there are other dangers. All these rotten plants that is being pushed under huge water pressure inside the reservoir in the hydroelectric dam, they may be turned into methane that eventually it can cause release of high amount of greenhouse gases. So we need to be careful about hydro. And then the ocean, wind, nuclear, biomass, solar, all these produce very little CO2 relatively, but there are still some CO2, because we must remember that, for example, to produce solar PV, you need to use energy. You need a high amount of energy to produce every panel. So there are some CO2, what we call cost, to produce energy from renewables. Okay? Even wind, you need to produce those wind turbines. There are some manufacturing process. All this energy will cause some CO2 to be released to the atmosphere. So in summary, we should try to go to the left of the charts here, or the figure here, because they produce very little carbon dioxide compared to fossil fuel, which are natural gas, oil, and coal. And when we focus on renewable itself, we will see that currently the bulk of renewable energy are from hydro electric power plant. Okay, and then it is followed by wind, solar, and then other renewables, up to 7,000 terawatt hour. Just a fraction of the total energy consumption by the world. Okay, so you can check the data from the link that is available down there.